Welcome back to part 2 of Module 8, Lesson 2, where we continue our study of the slope of the line. So far, we've looked at two approaches to find the slope. The first approach, we took and divided the rise by the run, where we counted on a graph how many units it rose and how many units it ran. Then, from there, we used the change in y divided by the change in x as a second approach to doing it. And now we're going to do a third approach, which is going to be another formula, only they're actually calling this one using the slope formula. All three ways we've done have been a slope formula, but this is what they're calling the slope formula, where we're going to use values x sub 1 and y sub 1 that you can see indicated right here. Those indicate 0.1, and x sub 2, y sub 2, those indicate 0.2. Now, in words, we're going to say the slope m, remember I told you in video 1 that slope is represented by an m, and the reason it's an m goes all the way back to some dead French guy. They think, they're not positive about this, but he called it the modius of the slope, and that's where the m is believed to have come from. But anyhow, the slope m of a line passing through point 1, which is x sub, like submarine, sub 1, y sub 1, and x sub 2, y sub 2, is the ratio of the difference in the y coordinates and the corresponding difference in the x coordinates. Now, if you were to take and model that, you would be saying that this point here is x sub 1, y sub 1, also known as point 1, and this point here, x sub 2, y sub 2, also known as point 2. And it really doesn't matter which one you call point 1 or point 2. You're going to get the same answer either way. Moving from there, looking at it in formula form, we have slope is equal to y sub 2, the y value of 0.2, minus y sub 1, the y value of 0.1, and x sub 2 minus x sub 1, where x sub 2 does not equal to x sub 1. Why is that important? Because if x sub 2 did equal to x sub 1, when you subtracted them, you would get a 0. And remember, you can never have a 0 in the denominator of a fraction because that always gives you an answer that is undefined. Now we get to watch a video about how to use this formula.
If you know 2 points on a line, you can use the slope formula to find the slope of the line. The slope of a line m is equal to the rise over the run, or the change in y over the change in x. To find the change in y, subtract the y coordinates. To find the change in x, subtract the x coordinates. So
now,
the slope...
take a look back right there. What did they just show you? They showed you all three of the formulas I've given you so far. The first formula, rise divided by run. The second formula, change in y divided by change in x. And the third formula, y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1.
So the slope formula is the ratio of the difference in the y coordinates to the corresponding difference in the x coordinates. Substitute the x and y values from both points in the slope formula. Use coordinates 1, 3 for x sub 1 and y sub 1, and use coordinates 5, 6 for x sub 2 and y sub 2.
Now remember I told you before, it doesn't have to be that. You could flop them and get the same answer. But what's important is that if you call this one having x sub 1, then the 3 has to be y sub 1. If you called 5 your x sub 1, then the 6 has to be y sub 1. That's what's important. It doesn't matter which one you call point 1 or point 2.
Now simplify. The slope of the line passing through the 2 points is 3/4.
Pretty simple, right? Just plug in your values, simplify it, easy math. And that leads us straight into example 2, where they give us point S and point R. They say find the slope of the line that passes through R, which is 0.12, and S, which is 0.43. So first thing they're going to have to do is, of course, write their formula. And the formula you can see they've used is y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. From here, the next thing that they're going to do is they're going to substitute in values. Now, let's take a look at what they did to see if it'll show us the original problem. They have point S is negative 4,3, and you can see that they've called negative 4,3 0.2. Point R was going to be 1, 2, and you can see they've called 1, 2 is 0.1. If you did it the other way around, you still get the same answer. So the y sub 2 is going to be this 3. The y sub 1 is going to be this 2. Your x sub 2 is going to be this negative 4. And your x sub 1 is going to be that 1. From there, of course, all you have to do is subtract. 3 minus 2 is going to be 1. Negative 4 minus 1, signs are the same. Find the sum. Sign from a larger number goes in front of your answer. That gives you a negative 5. So your final answer is going to be a negative 1 over 5. Really simple to do these things. Of course, you could take and plug that in right here, but you know, why bother when they give it to you? Now you take and pause the video and work extra example number 4 using that y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1 formula. How did it go for you? Well, the first thing I'm going to do is write my formula. That's the first thing you have to do on every problem of your homework. So my formula is going to be slope is equal to y sub 2 minus y sub 1 divided by x sub 2, whoops, I did that, divided by in the wrong spot, divided by x sub 2 minus x sub 1. From there, I'm going to call this as being 0.1 and this as being 0.2. So my y sub 2 is going to be that, negative 2, minus my y sub 1 is going to be that, which is going to be a negative 4. That creates an ugly problem. We'll deal with it later. My x sub 2 is going to be this negative 3, minus my x sub 1 is going to be that negative 7. Another ugly problem. Not a big deal because we're going to make the ugly problem pretty next. So I'm going to do a negative 2. Negative times a negative becomes a plus 4 divided by a negative 3. Negative times a negative becomes a plus 7. Therefore, we're going to have, now the top signs are different. Find the difference, which is 2. Sign for any larger number goes in front of your answer. On the bottom, signs are difference again. Find the difference, which is 4. Sign in front of the larger number goes in front of your answer. And the last thing we have to do is simplify 2 divided by 4. Well, we're going to rewrite that as 1 divided by 2. You don't have to write it as a decimal, although you could. I would stop at 1/2 there to indicate my slope, and of course you do need to check it. Fraction bar, a positive 1 divided by 2, accept and check, and the answer checks. But what if we had a line that was totally vertical or totally horizontal? What would the slope be? Well, the horizontal line, it's flat. You're not going up, you're not going down. What's the slope going to be? It's going to be 0. We'll talk more about that. The vertical line, though, that creates a whole new bucket of worms. It's kind of undefined. Let's take a look at this a little further. So we're going to take and press rise over run to extend the rise and run. What do we notice? We're going to drag point B down 1 unit at a time until the line formed between the 2 points A and B is going to be horizontal. And we're going to see what happens to the rise and run of the slope each time point B is moved down. Okay, so we're going to zoom out a little bit. We're going to add rise over run. And you can see right now your rise is 3. And your run is going to be 3. So your rise divided by 1, 3 divided by 3 is 1. If I drag point B down, you can see the slope just changed to being 0.67. Drag it down another one, your slope is 0.33. Drag it down, make it flat, and what did we get? We got a slope of 0 because there's no rise. You have a rise of 0 divided by run of 3. 0 parts of 3 is 0. That's the easy one. Anytime you get a flat line, 0, done. Of course, you do have to prove that with math. Now, from there, we're going to take and let's see what it says this time. The horizontal line is graph. We're going to move the line to make the line stop. See what happens when the line moves. What do you notice about points A and B? All right, so we're going to move the line, and it doesn't matter if you go up or down on that. Does the value of the slope change? No, it doesn't, because the ratio of rise to run is always going to be 0 over some number, so your slope still stays the same. Your slope is still 0 when you have a horizontal line. Now this time we're going to take and drag the A point to the side and see what happens to the value. You can see here that currently you've got a rise of 4 to a run of 4, and that gave you once again a slope of 1. Now if I take and move my A value one space to the right, I get a rise of 4 to a run of 3, also known as 1.33. Move it to the right again, I have a rise of 4 divided by a run of 2, giving us a slope of 2. Move it again, a rise of 4 to a run of 1, gives us a slope of 4. But watch what happens next time. Next, when I take and go one more trip to the right, I get a rise of 4 divided by a run of 0. And you cannot have 4 parts of 0. Therefore, anytime you get a vertical line like that, your answer is going to be undefined. Every vertical graph is going to have the same answer. It's undefined, because you cannot have any parts of nothing. And just like last time, it doesn't matter where in the graph it is. If it's going to be straight up and down, your answer is still going to be undefined, because the denominator, your change in your x value, is still going to end up being 0. Now that we spent a lot of time looking at that in pretty flashy things, let's slow it down and actually look at some definitions. The horizontal lines have a slope of 0, vertical lines have a slope of undefined. So we're going to take and highlight those two parts, because those two things are going to be very important going forward. So we're going to do that, and we're going to take and say that a 0 slope is going to be a horizontal line, a undefined slope is going to be a vertical line. Easy math, nothing to this stuff. Now we get to prove it using math. So we have point A, which is negative 3, 4, and we have point B, which is 2, 4. Notice the x values, the 4's, are going to be the same. They're going to subtract out to equal to 0. If we were to take and move forward and plug these into a formula where we're looking at the change in y divided by the change in x, also known as y sub 2 minus y sub 1, divided by x sub 2 minus x sub 1, when we plug in our values, that's going to give me 4 minus 4 divided by negative 3 minus 2. So on the top, I'm going to get a 0 over 5, also known as just 0 for the slope. So the slope of that line is going to be 0. Now, you get to do one of these on your own. Pause the video, do extra example 5. Alright, I set up my formula. Slope is equal to y2 minus y1. I'm going to call this to be point 1 and this to be point 2. That means that my y2 point is going to be 7 minus my y1 is also going to be 7. My x2 is going to be 5 minus my x1. That's going to become a negative 1. That gives me an ugly problem. Now the 7 minus 7, that's easy. We're just going to go and throw down a 0 for that. And on the bottom, I'm going to make that ugly problem pretty. Negative times a negative is a positive. So that's going to give me a final answer of 0 over 6, also known as just 0. We can jump back over to our textbook now. Plug in, I said jump back, there we go. Plug in that value of 0 for the slope. Wants it to be all fancy and stuff here. Accept and check. And the answer checks. Slope is 0. There's no rise compared to the run. But how about a undefined slope? Here you can see we get a line that is vertical, 100% straight up and down, and it gives you the point T, which is 1, 3, and U, which is 1, 0. It wants us to take and find the slope of it. We're going to work it the same exact way, starting with the formula. Slope is equal to y2 minus y1 divided by x2 minus x1. Plug in our values. The y2 is going to be 0. The y1 is going to be 3. The x1 is going to be 1. The x2 is going to be 1. So 0 minus 3, that ended up giving us a negative 3. Whoops, pushed the wrong button there. Hold on. Sorry about that. That ended up giving us a negative 3. 1 minus 1 is 0. And you can't have negative 3 parts of nothing. You can't have 0 in the denominator. So right there, the slope is undefined. That would be your answer for this problem. Now you get to take and do your very last practice problem before starting your homework. Do extra example number 6. So we're plugging in our values here. Our y sub, we'll call this one here 0.1 and this one here 0.2. So our y2 is going to end up being a negative 1 minus our y1 is going to be 4. Next, our x2 is going to be a 2 and our x1 is also going to be a 2. On the top, I have signs are the same. Find the sum with the sign in front of your larger number going in front of your answer. And on the bottom, 2 minus 2 is 0. Since we cannot have we cannot have 0 as a denominator, I should say, or negative 5 parts of nothing, we can take from there and write our answer is undefined. And yes, I did write that in cursive, which means most of y'all have no idea how to read it. My handwriting is kind of bad though. That is going to be it for this lesson. Stop your video, do your homework, make sure you're including formulas, because if you do not have formulas, I will not give you credit for doing your homework. I'll see you in class tomorrow.